Okay, so hyperbolas, Unit 12, Day 4. This is the last thing that we have to learn about graphing. So let's just get into this. A hyperbola is just an inside-out ellipse. That's really all it is. Okay, so the midpoint between the two vertices is called the center, same as it always has been. Plural of the focus, that's the foci, still pretty much the same. The endpoints of the transverse axis, that's kind of like our major axis. Those are the vertices. The line that divides a figure into 2 points that are mirror images is the axis of symmetry. The line segment of length 2b that is perpendicular to the focal axis with the center of the hyperbola at its midpoint is the conjugate axis. The segment connecting the two vertices is the transverse axis. The number A is the semi-transverse axis, and B is the semi-conjugate axis. Okay. This is what the hyperbolas look like. And A is always the first term. So if we look at this, A is always the first term. I want you to draw a line down right here. This is when the center is at 0, 0. So if X comes first, that means that my transverse axis is horizontal. That's the X axis. Okay, if Y comes first, that still means that A is first. A is always first. It just tells you that now this is vertical, so my transverse axis is the Y axis. So I'll write it down again. A always comes first. Super important. Okay? Let's just get into some of these. So remember, A is the first term, B is the second term. X came first here, so my transverse axis is the X axis. A squared is 9 because it came first, which means A equals 3. And B squared is 16, which means B equals 4. Now, if you flip back to that page before, you find C using C squared equals A squared plus B squared. Whereas with ellipses, it was A squared minus B squared because our focuses are inside, so you have to subtract it. But now our focuses are outside because these are inside-out ellipses, so it's A squared plus B squared because you have to add it to it. If that makes sense. So then that's going to be C squared equals 9 plus 16. C squared equals 25. So C equals plus or minus 5. That's 5. Okay, let's draw our center. Now, my A is 3. And my transverse axis is the x-axis. So I'm going to go out 3. That's left and right. So I'm going to go 3 to the left, or 3 to the right, 3 to the left. Now my B is 4, and that's up and down because it's just the opposite of what my other one was. So I'm going to go up 4 and down 4. Once I have those 4 points, I'm going to draw a box. Okay, this box makes it easier to actually graph this. Then once you draw a box, we're going to draw asymptotes. And you do that by drawing lines from corner to corner of the box. So there's that asymptote. And there is that asymptote right there. Okay. Then last thing I'm going to do is I'm going to plot my focus. So C equals 5, and it's always on the transverse axis. So I'm going to go out 5 to the right and out 5 to the left. And there's my focuses. And then a hyperbola, again, is just an inside-out ellipse. So that's going to go that way, and that's going to go that way. And they're just basically parabolas. They're just 2 parabolas that are back to back. Okay? Now I can go state my minor vertices, or let's state your major. I don't know why they put minor before major. Major, so that's 3, 0, and negative 3, 0. Minor is 0, 4, and 0, negative 4. The foci are 5, 0, and negative 5, 0. Then my asymptote. Slope, so it's always, that's a line. And slope is rise over run. So I rose 4 from the center and I ran 3. My asymptote is always plus or minus rise over run x. That's if our center hasn't moved. But since our center hasn't moved, it's rise over run, then x. So that's going to be 4 over 3 x. Plus or minus. You have to have the plus or minus. Okay? We're going to skip example 2. We're going to come back to it though. So let's go to example 3. Now, this always has to be set equal to 1. So let's divide by 144. You get x squared over 16 minus y squared over 9 equals 1. My transverse axis here is the x-axis because it came first. Now my major vertices, let's find them. So my a squared is 16, which means a equals 4. My b squared is 9, which means b equals 3. And then we have c squared equals a squared plus b squared. So 16 plus 9, 25. So c equals 5. Now let's just plot everything we have. So my center's at 0, 0. My a is 4, and I'm going to go left and right. So I'm going to go left 4 and right 4. My b is 3, and I'm going to go up and down. So I'm going to go down 3 and up 3. Now I have those 4 points, so I'm going to draw the box. Then I'm going to draw my asymptotes. And let's plot our focus, and it's in the direction of my transverse axis. So I'm going to go left 5 and right 5. There's that one, and there's that one. Okay, the major vertices are -4 and 0 and 4, 0. Minor vertices, 0, -3 and 0, 3. The foci are at -5, 0 and 5, 0. Then my equation, which we solved before, is x squared over 16 minus y squared over 9 equals 1. Last thing I want you to write is the asymptote. Remember, that's rise over run. So I went up 3 from my center, and I went over 4. So that's going to be y equals plus or minus 3 over 4x. Okay, now we'll go back to example 2. So we need to find the equation in standard form for a hyperbola centered at the origin, whose foci are plus or minus the square root of 3, 0 plus or minus the square root of 3, and vertices are 0 plus or minus 2. So that's what I know, and I know it's centered at the origin. So since my vertices are 2, that means that my a is 2, and that goes up and down because it's in the y. My foci are the square root of 5. It means that's my c equals the square root of 5. And then I can find b using c squared equals a squared plus b squared. So that's square root of 5 squared equals 2 squared plus b squared. So 5 equals 4 plus b squared. So 1 equals b squared, which means b equals 1. And that's going to go left and right. Okay, so I found a, b, and c. I can basically graph this now. So I have a center at 0, 0. My a value is 2, and it goes up and down. So I'm going to go up 2 and down 2. My b is 1. I'm going to go left and right. So right 1, left 1. Then I can draw my box, draw my asymptotes. Then the last thing, I need to plot my focus. That's the square root of 5, which is about 2 point something. So that's right there. Go down 2 point whatever it is. There's that parabola. There's that parabola. Okay, my equation is y squared over 2 squared, which is 4, minus x squared over 1, which equals 1. And you don't have to put that over 1 if you don't want. I just did. My vertices, the major vertices are 0, 2, and 0, -2. The minor vertices are 1, 0, and -1, 0. The transverse axis is the y-axis, and my asymptotes are plus or minus 2x, because I rose 2 and went over 1, so 2 over 1 is just 2. Okay, let's do these last ones. So if the transverse axis is vertical and is 4 units, and the central rectangle has a perimeter of 16, let's just draw this. It's vertical, which means it's going up and down, and that's 4 units. So that distance, that whole distance from bottom to top there is 4, which means the other side is 4. And I need a perimeter of 16. So that means that the top must be 4 and the bottom must be 4 also. And if that's 4, that means that that is 2. That distance there is 2, which means my a is 2 and my b is 2. So this is going to be y squared over 2 squared, which is 4. minus x squared over 2 squared, which is also 4, and that equals 1. And y came first because my transverse axis was the y-axis. It was the vertical axis. Okay? Now, area of the central rectangle is 8 square units, and we have vertices at -1, 0, and at 1, 0. That means that that distance is 2. We know that the area is 8, so that length right there, the height, has to be 4, because area is length times width. So that small distance right there is 1. That larger distance is not that much larger, it's only 2. So my equation is x squared over 1 minus y squared over 4, and that equals 1. Okay, we're going to save the rest for class, take the quiz, see you tomorrow.